Hello, I'm Alistair Gittner, Head of Science at Stocksbridge High School near Sheffield. How are we going to be able to join these tracks together?
Do they burn it so it expands and they stick together?
Excellent. OK, so they could heat it here and the two lines could join together. That could work. To get the students hooked into the lesson, I'm going to ask them the question, how do we join railway tracks? How do engineers create these long lines of smooth railway line without having to carry in large amounts of metal?
Could they get a mould and just pour in liquid metal so it solidifies?
Yes, so that would be really good. Today we're going to do a safe version of the Thermite reaction. The classic Thermite reaction between iron oxide and aluminium is a reaction that's done many times in schools. But because of its inherent dangers, it's not something that you can get students to do. Today I'm going to do a type of Thermite reaction which students can do, still has all the same excitement and enjoyment, they still get to see the massive amounts of heat that's produced, but it's in a completely safe and contained way. This is a very simple reaction. All we need is zinc powder and copper oxide powder. We need to remind them to wear safety goggles. A couple of spatulas of each of the zinc oxide, the copper oxide. Mix them by passing them backwards and forwards between two pieces of paper. The students then make a line of the mixture and then with a Bunsen burner set to a blue flame, they heat strongly one end. And you're going to mix the two chemicals together and then you're going to set fire to them. Now, I'm not going to show you what happens, okay? You're going to find out what happens, all right? Off you go. So here the students will be setting up the reaction, getting their equipment out, getting ready to start to heat the chemical reaction so that they can see what happens. Depending on your class, this might be somewhere where you need to go around and just check that the students are actually using the amounts that you've just said and that they're obeying the safety rules, safety goggles, hair tied back, that sort of thing. On the whole, though, it's a safe reaction, so there's not a lot to worry about.
Cool.
This is a mixed ability Year 9 group. We can pitch this lesson at all different levels. So with some students, I might be looking at doing balanced equations, but with other students, I might just be getting them to enjoy the chemical reaction and look and see what's happened.
Am I doing this? Am I going to scream? Ooh! Oh, it's puffy!
Once the students have allowed this to cool for a few moments, what we can do now is to look for the copper. Take a beaker and some 2 molar hydrochloric acid. Slide the reaction carefully into the beaker. The acid will react with the zinc oxide that's formed, and we should see fairly quickly the brown colour of the copper coming out. Carefully pour away the acid, and that leaves the copper in the bottom of the beaker.
It's getting warm, isn't it? It's getting quite warm.
Because there's other chemical reactions happening at this stage, there's all sorts of other things that you can get the students to notice. So some of them over there had noticed that the actual reaction is getting warm, and so that again is another example of evidence of a chemical reaction.
It's gone like a chocolatey brown. It looks like my hair down when I'm washing my hair.
This particular reaction between copper oxide and zinc is one that they can really engage with, and because of the amount of energy and smoke that it produces, it's a real winner with the students, and that helps them remember the things that I need them to know about the reactivity series. They can see that they've made this new metal, which is part of our Thermite reaction. Then what I'm going to do is move on to get them to actually isolate it and weigh it, so that we can see actually how much copper we've made.
5.77.
For a more able group, I would get them to weigh it more precisely, and then we can move on to do mole calculations or percentage yield. And so the practical works at different levels. Now then, we might be able to think about what's left over as to what's being made the last bit. We've got zinc and oxygen and hydrogen and chlorine. We've made zinc chloride. What we're going to have left over?
You're going to have water, so it's H2O.
Excellent, okay. We're going to have water left over, which we poured down the sink. and that's going to be H2O. Okay? So that's our chemical reaction. That's our Thermite reaction.
I liked today's lesson because of the bright lights. It was a bit like a firework display, only little and not with fireworks.
I thought it were quite amazing that such a little amount created such a nice explosion.
I find it easier when I'm actually doing something than the bookwork because, well, it's just more fun, so it sticks in my head a bit better.